Hello, and welcome to DevSecOps with Shipwright and Tekton, a virtual talk for CDCon 2022. My name is Adam Kaplan. I'm a software engineer at Red Hat and a maintainer of the Shipwright project. Before joining Red Hat, I worked at a transportation-focused consulting company which helped companies ship freight containers. Today, I help companies ship Kubernetes containers, kind of the same thing.
And my name is Vincent Demeester. I'm a software engineer at Red Hat and a maintainer of the Tekton CD project. I'm also a maintainer of the Docker project, or Moby as you prefer. So I'm very deep into software containers and not into the freight, actual, real, tangible containers. So what's the agenda? Today we are going to demonstrate how to create a DevSecOps developer workflow with Shipwright, Tekton, and a few tools along the way. We'll define in a few words what is Tekton, what is DevSecOps, and we will showcase a developer inner loop that uses Shipwright to build container images with local source code. Then we will demonstrate how to run the same process in a GitHub pull request with Tekton pipeline as code. And finally, we will use the same CI toolkit to publish our image with signatures and provenance attestations using Tekton Chains.
Before we begin the demonstrations, we should really ask ourselves, what do we mean by DevSecOps? I'm sure you have probably heard this term a lot at the conference, and lots of different people have different meanings. So for us, generally, DevSecOps means that developers build and operate the software, and that this software can be trusted, audited, and we can verify its authenticity. Now, to do all of those things and build that trust, developers need to show the receipts, as they say, and we need to show lots of them. We developers need something called a software bill of materials, which provides the full ingredients list for our code. We need to cryptographically sign things like container images to prove that we were the ones who created the artifact. We need this new thing called a provenance attestation, which shows what steps we took to produce the artifacts. And depending upon what our security teams or other experts ask, we may need to provide much, much more. In keeping with that DevOps mindset, we want all of these things to be generated automatically and early in the software development lifecycle. We do this so that if there is a problem, particularly for a security problem, we catch these things early and before we push things to production.
So developers cannot do all of this on their own, but there is plenty of tools to help. In this series of demonstration, we are going to use the following to bring the receipts. First, we're going to use Co, which is a tool to assemble container images for Go application without a Docker file. Then Kubernetes cluster, of course, and an image registry. Those will be used both on our local development as well as on the CI. Shipwright and Tekton, again, those are for building. Those are the building blocks of our CI and of our local development. And on the CI cluster, we are going to extend Tekton with Tekton Chains and pipeline as code. We're going to use all these tools to document our application through the whole software lifecycle: coding, review, testing, and deployment. A small word of warning or caution: many of the things that you are going to see rely on alpha features in Tekton, plus a few features on Shipwright that may have not been accepted upstream just yet. So your experience is subject to change, perhaps dramatically in the future.
Let's begin with a simple Hello World Go application using our DevSecOps stack. For my local environment, I am running Red Hat Code-Ready Containers, which provides a Kubernetes cluster as well as a container registry. I have deployed Shipwright and Tekton on this cluster, which are also used by our CI system. Therefore, I can run builds with Shipwright locally and be confident that my code changes won't fail once I submit them for review. My team uses Co, which is optimized to build container images for Go projects. It can automatically generate a software bill of materials for my application and it doesn't require a Docker file. The Shipwright community has a sample build strategy for Co, which I have installed on my cluster. Now I need to configure a build for my application, which tells Shipwright where the source code exists and where the container image should be pushed. In my build, I tell it that we're getting source from GitHub. I tell it to use the Co build strategy. And then I'm going to tell it to push to the location of the internal registry on my cluster. So this is actually a service that is running on the cluster internally. This is the internal address. You can actually, on code-ready containers, access it outside of the cluster with a separate public route. So let's go ahead and apply this configuration. And once it's set up, we can use the ship command line to start our build. We pass it name, and with the follow option, we can tail the logs as the build executes. When the build completes, not one, but two container images are pushed to the OpenShift internal registry. We have one for the image and the one for its software bill of materials. Because I'm using code-ready containers, I can actually use the image stream API to inspect the images that have been published onto the code-ready containers cluster. So you can see that we have the tag for latest that has its own digest, and we have a tag for the software bill of materials. The name is pretty long. That is because the tag name represents the digest of the image that the SBOM represents. And to inspect this SBOM, we can use cosign to download it and then print it out. So we're going to download the SBOM. Since we're outside the cluster, we're going to use the external route to the registry. And now let's print the SBOM and inspect it. You can see that the SBOM is for my GitHub code. You can see that it depends on the Cobra library, which is used to create Go command lines, as well as the pflag library, which helps you pass command line options to your CLI. Now, this works for GitHub, but what if we're testing locally? We want to make sure that our changes don't break anything, and we want to see the results. Well, we can use the ship utility to upload our local source code and run the same Shipwright build as before. So I'll go ahead and change the greeting to hello CDCon. And now we'll use the ship utility to upload my local code and run the build. And as the build starts, you can see that we have uploaded our local source code. It has been placed in the source location for the build, and now the build is going to execute. Now that the build has completed, let's inspect the images and SBOMs. You can see that now we have a new image that has been pushed under our latest tag. It's got a new digest. And if we look at the other tags, we have this tag here that has the SBOM of our container image that we had just pushed. And we can use cosign to download it and compare the two SBOMs, and you can see that these indeed represent SBOMs for two different container images. So now that our code has been tested, we can verify that the build works. With our changes, we can go ahead and submit a pull request with our code.
All right, let's submit a change and create a pull request and see how RCI does things and see Shipwright, Tekton, Tekton Chains, cosign, etc. all in action together and generate the receipts. So I'm gonna commit something. So here I'm changed the hello world to hello from CDCon 2022. So hello from CDCon 2022. I'm gonna push it. Good, this is good. I can create the pull requests, and we'll see that
by creating the pull request, a pipeline run is going to be scheduled. While the pipeline run starts running, I will explain a little bit how pipeline as code works. So pipeline as code looks into the .tekton folder and will look for pipeline run objects in there. And then it will decide which one to run when based on some annotation. And it will look at the on-event annotation as well as the on-target branch, for example. Here, what it's going to do is this simple pipeline pull requests will run on events on pull requests, so create a pull request, update pull request, etc. And solely on pull requests created against the main branch. There's additional annotation here. We are using two more. One is the task one, which tells pipeline as code to fetch the task definition here, git clone, golong test, and golong build from the upstream catalog, and the max keep runs, which will help pipeline as code keep the cluster clean by removing the old runs. Pipeline as code also brings us with some variables. Here we are using the repo URL, which is going to point to our repo, the revision, which is going to point to the git commit of our pull request, the source branch, and the pull request number. There's additional one, but we were interested in using only those for this particular demonstration. And then if we look a little bit at the definition of our pipeline, it's going to do a git clone, and then in parallel it's going to do a go test using golong tests task definition, and it's going to schedule a shipwright build using the alpha feature of Tekton called custom task. So this is how we do, and it's going to push to the internal registry. So now I can go back to my pull request, see that it's all green. I can look a little bit more into detail, and it's telling me sometimes, etc. So now I can go into the cluster and see that it did run, it did succeed, and I have my git clone, my tests, and my build. And it's got created by pipeline as code. Few annotation and labels were added automatically. As you can see, the build task here doesn't show the same way as the other ones because we're using custom task, and this is true for pipeline as code as well as the OpenShift console. We don't support this alpha API very good because it's alpha, so it might change, it might break. So the pipeline succeeded, but we don't see exactly what happened. What we can do though is look into the build run that were created. So build run is the object from Shipwright. We see that there was a build run created 2 minutes ago that succeeded, and that build run was our own pipeline undoing. So it's this commit, this repository using the co-cluster build strategy, and it pushed the image onto the internal registry. We can be curious and see that Shipwright did create a task run, and the task run did use Go, pushed the image, and pushed the SBOM. And you can also look at the image stream and see that it did push it. There's a bunch of them here, but our own is here, the demo silicon 2021, and we have the digest. So all is good. We can merge our PR, confirm merge, delete the branch, and now if I'm going back here, I'll see that another pipeline run, and this time it's a simple pipeline push, so it's the other one. Again, you can go into the console, see what's happening. It's the same kind of things, but it's running a different the different pipeline. All right, it did the git clone, now it's doing the two other ones. We can go back, see if a pipeline run was generated. It did just now, and this time what we should see is that we are now pushing to the GitHub package registry on the latest, and the commit is different because it's the merge commit. Again, we can do the same thing. Go back, see the logs of our task run generated, and we can see that it did push it. And we can also see that our digest is there, our final image is there, GCR. I'm going to copy it for a later purpose. I can go into GitHub package and see that less than a minute ago, the latest image was built, as well as other things. There's the SBOMs, so the software bills of material that got published, the attestation that we'll dig a little bit deeper, and this is the signature as well. So now, what we can do is we can use cosign to look into a few things. First, we can use cosign to download the software bills of material from latest. It will show probably the exact same thing as Adam showed locally, because this is the same software. You can see all the dependency. I could have done the same using my the image using the digest. I can also verify the signature. Again, here I'm using latest, but let's use the one with the digest as well. Here I'm telling cosign to look for the public key on my cluster, and we'll see that it verified, the cosign is verified, everything is good, and it printed some data. You can also get the attestation, so it's a bit similar, it's just attestation, and we'll see again it was validated, and we have the payload. Note that we can get the exact same payload using Recore, and this time if for example I'm searching for this one, I have two UID. Let me just catch one, and I can ask for Recore for UID and format JSON GQ, and I'll see that my payload attestation here, e.g. is the same as the one that was published in my image. So I can use both of them to print more details around the attestation. If I'm digging a little bit more, attestation, I'm gonna decode, because this is based 64 encoded, decode and GQ. I can see more detail on how this image was built. I see some things, I see how it got invoked and the steps involved in building. So here we see we did a git clone, so this is the entry point used and the reference arguments, and some environment variable, which image used, etc. And similar, then there's the co-build that was used here, build push, etc. And yes, that's pretty much it. We went through doing this all in local to actually do a pull request, validate that it works on the CI, and push it later on the public registry, where we can have all the things we need: the software bills of material, the attestation, and the signature.
As mentioned previously, not everything you have seen here has been released or has a stable API. On the Shipwright side, both running the Shipwright build in a Tekton pipeline and the integration with Tekton Chains has not been accepted upstream just yet. Both of these are work in progress that we hope to include in future releases. There is also a proposed feature in Shipwright to automatically scan images during the build. The design of this is under active discussion through the community's ship enhancement proposal process. On the Tekton side, some work is needed to improve how Pipelines as Code reports the status of custom Tekton tasks. As you may have noticed, the result of the Shipwright build was not visible in our GitHub pull request. There's also work being done in Chains to group task run attestations together if they belong to the same pipeline run. This will give auditors the full context of what produced a container image in a Tekton pipeline. We hope you enjoyed this presentation and hope you have a great CDCon 2022. Thank you for joining us.
Thank you.